The second of our conditional selection statements is a switch statement. We're going to learn new C keywords, switch, case, default, and break in this section. Switch statements are somewhat similar to if statements. We can convert if statements to switch and switch to if. Let's look at a switch case statement and a generalized switch statement. It starts with the keyword switch, and we have parentheses, and inside here we have a variable expression. This variable expression, remember, will enumerate or evaluate to, we want it to evaluate to an integer value in this case, always an integer value. And then we're going to list the different cases that will execute based on the value of this variable x. So the way the statement works, right, when x is a 1, we'll go down here to case 1 and do the statements associated with case 1. When x is a 2, we'll go to case 2 and do the statements associated with case 2. So keyword switch, the variable that we want to evaluate, the integer variable we want to evaluate, inside parentheses, and then inside this block we're going to start left curly brace, right curly brace, start of the switch, end of the switch. And we'll see that we can have as many different cases as we need. These case values must all be constant values. None of them can be variables. And we can also have a default case, which is similar to our else branch. So that was the generalized switch statement. And you can compare it to the if-else statement, because here we'd say if expression 1, do this. So this would be expression 1. Else if expression 2. Case 2 would be expression 2. Do this. Else if expression 3, do these statements. Same as case 3. And then finally, else if expression n would be case n. We would do these statements. And you can see the default then is just the else branch. So if all these others were false, we would come down and execute these statements. Right. So here it is in flowchart form. We switch on some sort of conditional expression. Before, I just had an x here. We could do it as a variable. We could do it as a conditional statement as well. So some sort of conditional expression here. Based on the value of this expression, right? If this expression evaluates to 1, case condition 1 would be true, and we would then execute the statements associated with case condition 1. But if this conditional expression evaluates to 2, right, so this isn't so much a true and false. Remember, the if was a true and false. This is a numeric. So when this expression is 2, we would come down and do condition 2. When it was 3, we do condition 3, and so on until we reach condition n. Right? If none of these conditions were addressed by the switch statement, we would come down. All of these would be false, and we would execute whatever's in the default block. Right? Otherwise, then, what I want you to see over here is the keyword switch. Here's our expression, so our conditional expression, our left curly brace to start the switch, and then case constant expression 1. So case is a keyword of the language. Constant expression 1. This has to evaluate to some sort of constant integer value. Followed by the colon. So we haven't used the colon before, but we call these case labels, and there's a colon that follows each case label. Then we'll have statements that we want to execute. These statements do not need to be inside curly braces. You can have multiple statements. And then the keyword break. And what break means is don't go down and evaluate any of these other cases. We'll break out of this. So here, if condition case 1 is true, we would do this. We'd have to have a break statement here. The break statement would cause our flow of execution to come down and execute the code immediately following the switch statement. Right? So case labels, constant expressions in the case labels, however many C statements you want to execute, right, followed by a break, then to leave that case. Let's go ahead and see how we would code a switch statement if we want to test for an odd or even integer, and then compare it to the if statement. So here, if I switch on num mod 2, remember the modulus operator is used with integer data types only, anything in the integer family. It returns then the remainder. So anything modded by 2 could return a remainder of 0 or a remainder of 1. We'll address then case 0. So when num mod 2 returns a value or evaluates to 0, right, a remainder of 0, even numbers anything evenly divided by 2 leaves a remainder of 0, case 0, we print the message even number. And then we break. The break statement causes the flow of execution to leave the switch and execute any statements below. Otherwise, when we mod the number by 2, whenever the remainder is a 1, we have an odd number. So case 1 then would say, print out the message odd number. We would break out of here and then execute the statements following the switch. Now, a default isn't necessary here, because if you think about it, if num is an integer value, the only possible values can be 0 or 1. This code at the default should never ever execute, unless we've made some sort of logic error somewhere. So you can put a default in here, and in this case, then we just went ahead and printed out the message unknown. If the code ever gets here, we need to evaluate why, what error conditions made that happen. Notice, with the default section being at the end, you can place default at the beginning, right, or in other places, but typically we always place it at the end. In this case, we don't need the break statement because this is the end of the switch, so our program control flow will just go on. Here's how we would code then the corresponding or the equivalent if statement. So if num mod 2 equals 0, print even number. Else if num mod 2 equals 1, print odd number. Else print f unknown. So you can see then, this is your case 0, case 0. Here's your case 1. This result is equal to 1, right? And then this else is your default. So you can see then, go ahead and try to write one of these on your own. Try to write this one, and then if you write the if statement, convert it to a switch. If you write the switch, convert it to an if. All right, so this just gives you the same explanation that I just went over. I want to emphasize once again, these case labels have to be constant integer expressions. They can, remember that a character value is also an integer expression, so it can be a single character. It can't contain variables or function calls, like constant integer expressions. Break indicates the end of the case block and prevents the program from falling through and executing the code and all of the rest of the case statements below. In other words, I'll show you an example in a little bit. If we didn't have this break here, then when we had case 0, it would execute this and fall through and keep going until it either gets to the end or encounters a break statement. Right, so let's look at some legal and illegal switch case labels. So any integer type, they can be short, char, int, long, long. They can be signed or unsigned, positive or negative. Right, just remember, case label can't contain a variable or a function call. These are all legal. Case 5, 5 is an integer constant. Well, 3 minus 2 really is a constant value of 1. Normally we wouldn't write something like that. We would just write case 1. Case capital Z, so this is the character Z. We know it's a character because it has the single quotes around it. Remember, this has an ASCII integer value, so this is a constant. Case max, if we had defined max as a macro, so pound define max 10, this is the same as saying case 10, it's just a little bit more human readable. Right, so if you had used a preprocessor directive to define max as some constant value, then you could say case max, because remember, this is not a variable, it is a constant, right? The preprocessor substitutes the value 10 in there. These are illegal. Case X, notice that there's no single quotes around the X. We know this isn't a character. The compiler will interpret this as a variable name and say it's illegal. Also, calling a function, case printf hello, is illegal. This is not a constant value, right? If printf fails, it returns a 0. If printf succeeds, it returns a 5. So it doesn't always return the same thing. It's not a constant value. You cannot have a function call there. All right. I mentioned this earlier, that multiple statements inside your case statement blocks are not enclosed in curly braces. We don't use the curly braces there, just the beginning of the switch, end of the switch. We use the break statement to break out of that case statement block, right? And without that break statement, the program execution falls through. So it will execute every single line below, every single C statement below until it encounters a break or leaves a switch structure. Right. So let's go ahead and look at this. We've got a variable named grade. We've stored the character A in it. So if we switch on grade, well, we'll see then that case A is true, right? grade is equal to A, we go to case A, we'll see that the message excellent prints out on the screen. The break statement then causes control flow of your program to go down beyond the end of the switch. None of these other cases execute simply because we have the break statement there. Break says break out of this particular structure. Now, we have the same example here, but I've removed the break statements. Once again, grade is equal to the character A. But when we switch on grade, case A is true. We print out excellent, that message. So we see this output here. But because there's no break, without the break, this falls through to the next statement. So even though grade is an A, we still come down and we'll execute printing out good. No break statement there, we'll execute printing out fair, as we see here. No break statement there, so we'll print out fail. And no break statement there, we'll print out invalid grade. And this is not what we want. If the person has an A, we want to print out the message excellent. We don't want to print out all these other messages. So go ahead and try this in a program without the breaks and see how it falls through. Start putting some breaks in here and see what kind of output that you get. And that will help you remember to always put a break in when you don't want those other statements to execute. All right, let's take a look at what this program output is. Let's assume that the variable x has a value of 0. So when we switch on 0, well, that's the same. We'll go to case 0 because x is equal to 0, and we'll print out the message x is 0. Notice there's no break statement here. Well, then we fall through and we print out x, the message x is 0 or 1. The break statement causes us to stop executing any more statements below and break out of this structure. So when x is 0, we see the message x is 0, and then x is 0 or 1 print out. So what happens when x is 1? Well, case 0 isn't true, but case 1 is true. So we print out the message x is 0 or 1. The break statement tells us to leave. We break out of the switch structure. Finally, when x is 2, neither of these cases is true, so our only output will be x is 2. Because this is the end of the switch, we'll just go on and execute whatever code is below. All right, when should we use switch statements? We've seen switch, we've seen if. Right? So usually we use a switch statement when there's only one variable to evaluate in the expression. Right? A simple expression, just the variable name typically. Sometimes we'll also use it when there are many conditions to test. It's easier to write than an if statement, but it's better to show you examples to see that rather than just depending on this wording, because you're not sure. Well, what do we mean by there are many conditions to test? And that's what I said. Here's what I said up above. Switch statements are often used as an alternative to long if statements that compare a variable to several integral values. If x is equal to 1, do this. Else if x is equal to 2, do this. Else if x is equal to 3, do this. Else if x is equal to 4, do this. There's a little more typing to do than if we just said switch on x, case 1, case 2, case 3, case 4. And the switch statement is easier to read as well. So let's then go ahead and show an example where we can use multiple case labels to execute the same action. Remember our example where we wanted to print out the message of the number of days in the month? So we had this sort of if statement because we have several months, 7 of them, that have 31 days. So we have to check every single one of these. If month is equal to 1, go ahead and print this out. Or if month is equal to 3, go ahead and print this out. Month has 31 days. And then we go on to test else if, and we check for months with 30 days. All right, well, let's look at this. Here we have 7 different months that have 31 days. What we can do in terms of converting this to a switch statement is we can say switch on month, and then we can list all of these cases, case 1, case 3, 5, 7, 8, 10, and 12. So when any of these are true, it will execute this one action, this message month has 31 days. We need the break statement then so that it doesn't fall through and execute anything else. But you can have multiple case labels all perform the same action. We just list them one after the other like this. Right? Here, then, we can convert the month equal 4, or month equal 6, or month equal 9, or month equal 11 to this part of the case statement, or the switch structure, case 4, case 6, case 9, case 11. So we have 4 cases where the month has 30 days. Right? Now, we have one case, case 2, for February, where we print out the message the month has 28 or 29 days. Here, the else is comparable to the default, so we print out the message that we have an unknown month number, right? So you could write either one of these. It's up to you to write the one you're most comfortable with at this point, right? But you should get used to writing both of these. And for me, once I get used to the switch statement, this is much clearer and easier for me to read and find out exactly where I should go and what action will happen for that particular value of month. It's faster than reading through this and trying to figure out which one of these actions will happen. So now you can have some practice. Here's a table showing telephone area codes in the state of Georgia, right, along with the largest city in each area. So here's an area code, here's the major city. I want you to write a switch statement whose controlling expression is the variable area code. Controlling expression is the variable that you're going to switch on. You're going to switch on area code. Then I want you to print the name of the city for the values in the table. Otherwise, if the area code is a value not found in this table, you want to display the message area code not found. And make your switch statement as simple as possible. Right? And you'll notice some of these, Atlanta has 1, 2, 3 area codes. So you want to have all 3 of those cases for Atlanta. You can use those multiple case labels just to perform that one action, print Atlanta. So go ahead and try that on your own. Write the program, write the switch statement, test it. Don't forget your break statements, and practice inputting some different area codes. I'd use a scan F to read the information in from the keyboard and get this program running. It's good practice. After you get the switch statement done, you could also try, then I'd take the switch and convert it to an if. It will give you good practice with both of those new decision statement structures. Right? And if you want to look ahead, right, I've got a solution there for the switch statement. That's one way of doing it. Right, probably the most clear. Last of all, there is a conditional operator in the C language. And believe it or not, this is an operator, question mark colon. It works just like an if-else structure. We call this a ternary operator because it actually requires 3 operands. We have some sort of expression 1, question mark, expression 2, colon, expression 3. This expression is your if condition. Whenever this condition is true, it goes over and performs everything in this section labeled expression 2. When this condition is false, it will perform everything in expression 3. Right. So we read this, if expression 1 is true, then do expression 2, else do expression 3. Okay, so let's look at some example usage. Here's a test, 1 less than 2. This will be true. When this is true, it will execute the code printf true. Right. This statement should never execute false, and I need some double quotes around there. There's a typo that I'll fix. Right, should never execute false. Let's look at this now. Sum greater than 10. Well, as the value of sum is greater than 10, the action that will be performed is subtracting 5 from the value of sum and storing it back in sum. Otherwise, then when this is false, if sum is less than or equal to 10, we'll just simply add 1 to what's stored in sum. This expression is equivalent to if sum is greater than 10, sum equals sum minus 5, else sum plus plus. Right? You can write either one of these. I think for a beginning programmer, this is more English-like. It's easier to read. I would stick with writing this. Once in a while, this operator, this ternary operator, can come in handy. All right. Now, we just finished the last of our conditional branching statements. There is an unconditional branching statement that's part of the language. You rarely, if ever, rarely ever see it used. It's called the goto statement, and it's called unconditional branching because you always go to that area of code with no test, so no test condition. Right. So a keyword goto, it's used to transfer control to a specified label. So we're going to have a label similar to a case label, just without the word case. Right. So the label is an identifier specifying where in the code the branch is to be made. And this label can be any valid identifier name followed by the colon. So we could say goto, and if this case name is label, goto label, right? It would skip over all these lines of code, go down here, and execute whatever statements follow label all the way to the end of the program or until there was some other branching statement. This is called a forward jump because we go forward in the code. Otherwise, is your program's executing if you're up here? Well, it will basically ignore the label, execute all these statements, go down here, and then when it says go to label, it will come back up here and execute whatever statements follow this. Right? If there's nothing else to make it branch, it will just keep cycling around. We call it a backward jump because we go backward in the code. This is very poor coding. It is never used anymore. Right? So here is your warning for this course. Goto violates the rules of structured programming. It makes code more complicated and makes the program unreadable. You know, a program with one goto is fairly readable, but with several gotos, becomes very unreadable because you can be jumping all around. Try to imagine a program that maybe had 100 lines that had you jumping forward and backward all over the place. It's very hard to understand how the program executes. It's very difficult to maintain. Gotos were used a long time ago when people started writing code when computers were new. They hadn't formed all these ideas of structured programming. And in terms of the C language, we're soon going to start writing our own functions. But when we want to have a certain set of actions happen based on the test condition or based on other conditions in the code, we will call that function normally. Same way we call printf. Right? We call printf and scanf functions that are written in other libraries. It's very handy to call that function. We wouldn't want to have to put all of the code for scanf and printf and every single C function in our code and have gotos to go back and forth. It would get very confusing. So there are better ways to branch program control. We often rearrange code. Don't ever use a goto in this class, right? We consider it better programming style to use the break, continue, and return statement in preference to a goto. And pay attention to this. Use of a goto in this course will earn you a failing grade on any assignment or exam. So if you use a goto statement anywhere in one of your programming assignments, you will get a 0 for that assignment. If you use it on a quiz, you will get a 0 for the quiz. If you use it on an exam, you will get a 0 for that whatever problem that is on that exam or quiz. Do not use a goto statement. All right, and that's the end of our lecture on control structures, branching structures.